Welcome to EPG Pathshala. Students, in today's module, we are going to discuss on physico-chemical properties of fuel. All the fuel have the different physico-chemical properties. The understanding of these properties is very important. This knowledge helps us to understand the performance and efficiency of the engine in which it is used. These properties varies with respect to the solid fuel, liquid fuel and gaseous fuel. In this module, we will be mainly dealing with these physical and chemical properties. In the case of coal, these properties vary from type of the coal. All the fuel have the calorific value, and it is the most important property of any fuel which helps to measure its efficiency. In the case of liquid fuel, the other properties like viscosity, ash content, moisture content, etc. are also effective. So, in this module, we are going to deal with the properties of solid fuel, properties of liquid fuel and properties of the gaseous fuel. And we will also see what is proximate and ultimate analysis, mainly with respect to the coal content. Let us start with the properties of liquid fuel. The first property is the density. Density is mass by volume, that is the ratio of mass of the fuel to the volume of the fuel with reference to a particular temperature, and mainly it is 15 or 20 degree Celsius is used as the reference temperature. The unit of density is kilogram per cubic meter. You can see in this table different densities of different liquid fuels. Crude oil has a density of 900 kilogram per cubic meter, and it ranges from on an average it is 900 kilogram per cubic meter, and it has a range of 700 to 1000 kilogram per cubic meter. Gasoline has a density of 750 kilogram per cubic meter with a range of 720 to 760. This density helps the oil to float on water because it is lighter than the water. Diesel, the density is 830 kilogram per cubic meter with a range of 780 to 860 kilogram per cubic meter. In the case of biodiesel, it is around 880 kilogram per cubic meter. In the case of wood, it depends mainly on the water or the air content. So, the maximum for the hardwood is 1550 kilogram per cubic meter, and softwood has a density of 50 kilogram per cubic meter. This is measured by an instrument known as hydrometer, and the density is very important to quantify the calculations and as well as estimating the ignition quality of a fuel. Another property is the specific gravity. It is the ratio of the weight of a given volume of oil to the weight of the same volume of water at a given temperature. That is, it denotes the density of fuel with respect to water, and the specific gravity of water is hence 1. Then this property has no units since it is a ratio, and here since the density is measured, hydrometer is used for this for the estimation of the specific gravity. This table shows the specific gravity of various fuel oil. Light diesel oil has a specific gravity of 0.85 to 0.87. Furnace oil has a specific gravity of 0.89 to 0.95. Low sulfur heavy stock oil has 0.88 to 0.98. Another important property is the viscosity. It is the measure of the internal resistance of a fluid to flow, that is the resistance offered by a fluid while flowing. It depends on the temperature, and the temperature and viscosity are inversely proportional. That means viscosity decreases as the temperature increases. So, if we are mentioning any viscosity values, the temperature has to be mentioned, otherwise it has no meaning. The unit of viscosity is Pascal second in SI unit and centipoise in CGS unit. Each type of oil has its own temperature viscosity relationship. There are two types of viscosity, dynamic and kinematic. Dynamic viscosity expresses the resistance to the shearing flows, where the adjacent layers move parallel to each other with different speeds, and it is normally denoted as nu. The kinematic viscosity is the ratio of the dynamic viscosity to the density of the fluid rho, and it is expressed as nu, that is equal to nu by rho. Normally, the kinematic viscosity is used as a property to compare the fuel efficiency. It is normally measured by the instrument known as viscometer. It is an important characteristic in the case of storage and the use of fossil fuel. It influences the degree of preheating that is required while handling, storage and for the satisfactory atomization. If the oil is too viscous, that means too thick, there is difficulty in the pumping and it is very difficult to light the burner and it is very difficult to operate. The poor atomization also result in the formation of carbon deposits on the burner tips or on the walls. So, the viscosity is very important property in the case of a liquid fuel. The crude oil has viscosity in the range of 5 to 20 into 10 to the power minus 6 meter square per second. Gasoline has 0.5 into 10 to the power minus 6 meter square per second and diesel has an average of 3 into 10 to the power minus 6 meter square per second with a range of 2 to 4 into 10 to the power minus 6 meter square per second, and the biodiesel has a range of 4 to 6 into 10 to the power minus 6 meter square per second. Here you can see that the crude oil has a little bit more viscosity than the gasoline and the diesel. Another important property is flash point. It is the lowest temperature at which the fuel can be heated so that the vapor gives off flashes when an open flame is passed over it. That means it is the point at which it starts burning, and the crude oil has a flash point of 230 Kelvin, diesel 310 to 340 Kelvin, wood 310 Kelvin and furnace oil 339 Kelvin, and for the biodiesel it is 370 to 430 Kelvin. It is derived from the biomass, so it has a little bit more flash point. Pour point, it is the lowest temperature at which fuel will pour or flow when cooled under prescribed conditions. So, flash point is the lowest temperature at which it starts igniting, while pour point the lowest temperature at which the pouring ability or the flowing ability stops when it is cooled under the prescribed condition. This shows the degree for the readily pumpable, whether the fuel is readily pumpable or not. It helps to understand performance of fuel during the winter time, because this time the temperature is very low, and if the fuel has a low, if the pour point is low, then it will be very difficult for the engine to work. So, the pour point of crude oil is around 278 to 288 Kelvin. What is specific heat? It is the amount of kilocalories needed to raise the temperature of 1 kilogram of oil by 1 degree Celsius. The unit of specific heat is kilocalories per kilogram degree Celsius, or it can also be expressed as joule per gram per degree Celsius. It varies from 0.22 to 0.28 depending on the oil specific gravity. So, specific gravity is related with the specific heat, and this property helps us to understand how much steam or the electrical energy is required to heat the oil or the fuel to a desired temperature. Light oils have low specific heat, whereas heavier oils have a high specific heat. Calorific value, it is some measurement of heat or energy which is produced while oxidizing in an ideal condition. There are two types of calorific value: gross calorific value, which assumes all vapor is produced during the combustion process is completely condensed, while the net calorific value assumes the water leaves with the combustion products without fully being condensed. Normally, the NCV or the net calorific value is used for comparison between the fuels. The calorific value of the coal varies with respect to its ash content, moisture content, type of coal, while calorific value of the fuel oil is almost consistent and is normally measured by Bohm calorimeter. You can see in this table the calorific value, heating value of different fuel. In gasoline, the high heating value is 45.7 megajoule per kilogram and the low heating value is 42.9 megajoule per kilogram. In the case of diesel, it is high heating value is 47 and low heating value is 43 megajoule per kilogram. The biodiesel has the high heating value of 40 megajoule per kilogram. Coal, in the case of coal, the high heating value is 32.8 megajoule per kilogram. This is for the pure carbon. And with respect to the enthalpy, you can see that C plus O2 produces CO2 plus 393.5 kilojoule per mole. So, here the actual coal have a heating value which is made up of the contribution from the carbon, hydrogen, sulphur oxidation. Assuming that these bonds are free and this minus the contribution of existing bonds, particularly those with the oxygen, the bonding with the oxygen which could not be further oxidized. So, here the oxygen content reduces the heating value for the complete combustion, since it is already bonded to hydrogen and carbon atom. In the case of wood, the heating value depends on the moisture content, and the maximum value is for the dry wood, that is 20 megajoule per kilogram. Wood pellets have a high heating value of 17 to 18 megajoule per kilogram, and logwood high heating value is 15 to 16 megajoule per kilogram, and wood chips it is 13 to 15 megajoule per kilogram. And if you see that wood as per the moisture content reduces its high heating value, increase. The wood when it convert to coal, it has little bit more heating value, and compared to coal, the gasoline and diesel are having the high heating value or the energy content in it. Vapor pressure. It is defined as the pressure exerted by its vapor in phase equilibrium with its liquid at a given temperature. Normally, saturation pressure is same as vapor pressure for any pure substance. If you see the vapor pressure for the crude oil, it is in the range of 5 to 20 kilopascal at 20 degrees Celsius. Vapors are normally heavier than the air. It is 2 or 3 times heavier than the air. In the case of gasoline, 50 to 90 kilopascal is the vapor pressure, and diesel the vapor pressure is 1 to 10 kilopascal. It is 0.5 to 5 kilopascal for the kerosene. The sulphur content, it is the amount of sulphur content in the fuel oil. It depends mainly on the source of the crude oil and to a lesser extent its refining process. The normal sulphur content of the residual fuel oil is 2 to 4%. You can see in this table the kerosene has a sulphur content of around 0.05 to 0.2, diesel oil has 0.05 to 0.25, the light diesel oil has 0.5 to 1.8, furnace oil has 2 to 4, and the low sulphur heavy stock oil has less than 0.5% of sulphur content. Now, what is the significance of the sulphur content? It has main disadvantage of the risk of corrosion, which is caused by the formation of sulphuric acid during and after the combustion, and the condensing after the combustion, it gets condensed in the cool parts of the chimney or the stack or the air preheater, and it causes the corrosion. Ash content, it is related to the inorganic material present in the fuel oil. This residual fuel have more of the ash forming constituents. These include the compounds of sodium, vanadium, calcium, magnesium, silicon, iron, aluminium, nickel, etc. The ash value is normally in the range of 0.03 to 0.7%. If excessive ash is present in liquid fuels, it causes fouling deposition in the combustion equipments. Ash has also have erosive effect on the burner tips. It causes damage to the refractories at high temperatures and even give rise to high temperature corrosion and fouling of the equipments. Ash content is the inorganic, the amount of inorganic residue present. The organic residue present in the fuel oil is known as the carbon residue. The tendency of oil to deposit a carbonaceous solid residue on a hot surface is common. It is mainly on the burner or injection nozzle when its vaporizable constituents are evaporated. So, carbon residues are deposited on these parts. The residual oil contain carbon residues which range from 1% or more. The moisture content, this water that is present in free or emulsified form and can cause damage to the inside furnace surface during combustion, especially if it contains some salt in it, is known as the moisture content. That is the amount of water present in the oil. The maximum limit which is specified in the standard is around 1%. If it is exceeding, then it will cause some damages. It causes spluttering of the flame at the burner tip, possibly extinguishing of the flame, and also reduce the flame temperature or the lengthening of the flame. You can see anthracite coal has a moisture content of 5 to 15%, while lignite has 30 to 60% moisture. The wood moisture is around 20 to 80%. This table shows the specifications of various fuel oils. You can see the properties which we have already discussed, like density, flash point, pour point, the gross calorific value, sediment percent, sulphur content, water content and ash content of different oils in this table. Now, what is octane number? This is a measure of auto ignition resistance in a spark ignition engine. It is the volume percentage of isooctane in a isooctane N-heptane mixture having the same anti-knocking characteristics when tested in a variable compression ratio engine. Normally, it has a range of 92 to 98. The octane number of gasoline is around 92 to 98. Another important thing is the cetane number. As the octane number related with gasoline, cetane number normally related with the diesel fuel. This is the measure of fuel's ignition delay, the time period between the start of injection and the start of combustion, that is the ignition of the fuel. So, that is between injection and ignition. With larger cetane numbers, the fuel with larger cetane numbers have low ignition delay. This is mainly meant for the compression ignition engine, and it is useful for the light distillate fuels, because in heavy fuel oil a different burning quality index is used, and normally the cetane number is between 40 to 55, that is on an average it is 45, and for biodiesel it is 60 to 65. If you see the cetane number of gasoline, normally it is not used, but if it is present, then if you check that value, you will be getting only 5 to 20, in between 5 to 20. Here the gasoline has a relatively large time lag between the injection in hot air and auto ignition. This cetane number is irrelevant to the gasoline because it is an SI engine, spark ignition engine, rather than a compression ignition engine. So for the gasoline it is octane number, you have to see the octane number of the fuel, and for the diesel engine for the diesel we have to see the cetane number. Now we will see what are the properties of coal. The major or the most important physical property is the heating value. The heating value of coal varies from one place to another, from the type, ash content, moisture content, etc. Apart from that, it also varies from place to place. You can see in this table the gross calorific value of different coal. You can see Indian coal is around 4000, Indonesian coal it is 5500, South African coal it is 6000. Here the Indian coal is of the less calorific value, or you can say it has a low grade quality. Based on the calorific value, the gradation has been given to Indian oil like A, B, C, D, E, F, G. The A grade coal has a calorific value exceeding 6200, B 5600 to 6200, C 4940 to 5600, D grade 4200 to 4940, E grade coal has calorific value of 3360 to 4200, F has a calorific value of 2400 to 3360, G has calorific value of 1300 to 2400. Normally in India or in Indian industry, the coal grades are D, E, F. So you can see the poor quality of coal used in the industry, and that leads to the emissions, and the chemical composition of coal has a strong influence on the combustibility nature of the fuel. Apart from this, the other properties like moisture content, that is the water content present in the coal, also affects its combustibility. And next is fixed carbon. It refers to carbon in its free state, that is not combined with any other elements, also determines the ability of the fuel or the efficiency of the fuel. And another one is volatile matter, which refers to those combustible constituents of coal that vaporize when coal is heated. How to measure these parameters? First we will see how to measure the moisture. It is normally measured by the hot air oven method, that is the sample is placed at a temperature of 105 plus or minus 2 degree in a hot air oven with the lid. Now after 8 hours the sample is taken out and cooled to room temperature and it is weighed. The loss in weight represents the moisture content. And how to measure the volatile matter? The volatile matter present in the sample is measured by taking a fresh sample in a covered crucible and heated it under a temperature of 900 plus or minus 15 degrees Celsius in a furnace, and the sample is taken back and cooled and weighed, and the loss of weight represents the volatile matter. How to measure the carbon and ash content? The cover from the crucible which is used for the volatile matter estimation is removed, and the crucible is heated over the burner until all the carbon is get burned. The residue is weighed, which is the incombustible ash. Difference in weight from the previous weighing is the fixed carbon. That is, fixed carbon is derived by subtracting from 100 the value of moisture, volatile matter and ash. The coal is a natural composite material consisting of a mixture of compounds in it, and it is measured by weight and referred as either received oil or wet coal basis, or on a dry basis, or on a moisture free, ash free basis. So how to analysis this coal? There are two methods: ultimate analysis and proximate analysis. Ultimate analysis determines all the coal component elements, that is solid or gaseous. Here it is fixed coal plus volatile coal plus ash plus water. That is the proximate analysis. It determines only the fixed carbon, volatile matter, moisture and ash percentage. While in the ultimate analysis, it is estimated as water plus percentage of carbon, hydrogen, oxygen, nitrogen and sulfur. So, in the ultimate analysis it is the chemical properties are measured, while in the proximate analysis physical properties like fixed coal or fixed carbon, volatile matter, ash and water content is measured. So, the ultimate analysis is determined in a properly equipped laboratory by a skilled chemist, while proximate analysis can be determined with a simple apparatus. Proximate analysis, it indicates percentage by weight of the fixed carbon, volatile, ash and moisture content in the coal. The amount of fixed carbon and volatile combustible matter contribute directly to the heating value of the coal. The fixed carbon act as a mean heat generator during the burning process. If the volatile matter is high, it indicates easy ignition of the fuel. The ash content is important in the design of furnace grade, combustion volume, pollution control equipments and ash handling systems of a furnace. So, once you know the components of the proximate analysis, you can improve the efficiency of the furnace or the engine. Now, what is the significance of these parameters in proximate analysis? Fixed carbon, as we have seen, it is a solid fuel left in the furnace after the volatile matter is distilled off. Mainly consists of carbon and some hydrogen, oxygen, sulfur and nitrogen, and this gives a rough estimate of the heating value of the coal. So, in fixed carbon relates with the heating value of the coal. Volatile matter, which includes the methane, hydrocarbon, hydrogen and carbon monoxide and incombustible gases like carbon dioxide, nitrogen, which is found in the coal. It is an index of gaseous fuel and it ranges from 20 to 35%. This is proportionately increases with flame length and it helps in the easier ignition of the coal, and it sets minimum limit of the furnace on the furnace height and the volume, and it influences the secondary air requirement and distribution aspect. The volatile matter also influences secondary oil support. The ash content is the impurity that will not burn and it normally ranges from 5 to 40%, and it reduces the handling and burning capacity, increases the handling cost. If the ash content is more, the cost will be high. It affects the combustion efficiency and the boiler efficiency, and it also causes clingering and slagging. Moisture in the coal while transporting, handling and stored is important. Since it replaces the combustible matter, it reduces the heat content per kilogram of the coal, and it typically we have seen the range is between 0.5 to 10% moisture, and this moisture content increases the heat loss because of the evaporation and superheating of vapor. It helps to some limit in binding and it also aids in radiation heat transfer. Sulphur content affects clingering and slagging tendency. It has a slagging tendency. It corrodes the chimney and other equipment, and it limits exit flue gas temperature. So, this table shows the proximate analysis of various coals. You can see the moisture, ash, volatile matter and fixed carbon for different coals like Indian coal, Indonesian and South African coal. You can see the fixed carbon is less in Indian coal, fixed carbon as well as volatile matter is less in Indian coal, and ash content is high in the Indian coal. The chemical properties is analyzed by chemical properties of the coal is done by the ultimate analysis. It indicates the various elemental chemical constituents such as carbon, hydrogen, oxygen and sulfur. It is useful in determining the quantity of air required for combustion and the volume and composition of the combustion gases. This is required for the calculation of flame temperature and the flue duct design. Now, what is the relationship between the ultimate analysis and proximate analysis? The percentage carbon is equal to 0.97 carbon plus 0.7 multiplied by volatile matter minus 0.18 minus m multiplied by 0.6 minus 0.01 m. Here C is the percentage of fixed carbon, A is the percentage of ash, Vm is the volatile matter percentage, M is the moisture percentage. So, from this fixed carbon we can find out the percentage carbon. Similarly, percentage hydrogen is equal to 0.036 multiplied by carbon percent plus is added to the 0.086 multiplied by difference in the volatile matter and the product of 0.1 and ash content. It's deducted from 0.0035 m2 multiplied by 1 minus 0.02 m, and nitrogen the percentage N2 is equal to 2.10 minus 0.020 Vm, and this equation is only valid for the coal which contain greater than 15% moisture content. The properties of gaseous fuel. The calorific of gaseous fuel is expressed in kilocalories per Newton cubic meter, that is at the normal temperature and pressure, and you can see the comparison of this net calorific value of different gaseous fuel. It has properties like density, higher heating value, air fuel ratio, flame temperature, flame speed, etc. You can see the natural gas, propane and butane, how these are differ in their heating value. The heating value for natural gas is around 9350. So, the compositional analysis of gas mixture is normally done by the ORSAT apparatus. It is a standard apparatus in which normally the carbon dioxide, carbon monoxide, oxygen and nitrogen gas composition in volume percentages are measured. Sometimes hydrogen, methane and unsaturated hydrocarbons are also measured using this apparatus. This apparatus consists of a graduated burette up to 100 divisions from bottom to top, an aspirator bottle, a series of pipettes having necessary fittings and a 3-way stopcock connecting to the top of the burette to the gas stream. The pipette contains an adsorbent for removing the one gas. The adsorbents used are caustic potash solution, freshly prepared alkaline pyrogalol solution and cuprous chloride in ammonia solution for the removal of carbon dioxide, oxygen and carbon monoxide. Normally, the unsaturated hydrocarbons are removed by using bromine solution. Next, this figure shows the ORSAT apparatus. The diagram of this is the diagram of the ORSAT apparatus. You can see the different parts of the ORSAT apparatus in this one. It is marked A. The A is the graduated glass tube. D, C, B are the pipettes containing KOH, alkaline pyrogalol, bromine solution and ammonical cuprous chloride solution. F is the stopcock and G is the aspirated bottle and H is the rubber tube. The comparison of chemical composition of various fuels. The crude oil, it contains saturated hydrocarbon around 60%, aromatics around 30%, resins 5%. The sulphur content is 0.5 to 2%. Heavy metal is less than 100 ppm and the vapors are mainly the short chain hydrocarbons. The dry coal composition is 85% carbon, 5% hydrogen, 5% oxygen and 5% ash by weight. Sulphur content is 2 to 10%. The remaining 70 to 90% is dry ash free coal, which is divided into volatile matter, which accounts 20 to 40% by weight, and fixed coal, fixed carbon, which is the solid, the other part of the solid residue. So, the carbon content in this coal range from 80 to 90% by weight. The hydrogen content in the coal range from 5 to 6% by weight, oxygen 1 to 10% by weight. Now, the oxygen present in this decreases the theoretical air required for the complete combustion of fuel and its heating value. The high heating value reduction per kilogram of oxygen is around 17.9 megajoule per kilogram if combined with hydrogen or 12.3 megajoule per kilogram if combined with carbon. That is, if it is combined with hydrogen means H2 plus half O2 gives H2O plus 286 kilojoule per mole. So, using this one, the oxygen content is 17.9, while carbon plus oxygen equals or producing carbon dioxide plus 393.5 kilojoule per mole, it will produce 12.3 megajoule per kilogram. The higher heating value of a coal in terms of dry ultimate analysis is calculated as U percentage carbon plus V percentage hydrogen plus W percentage oxygen plus X percentage nitrogen plus Y percentage S plus Z percentage ash. Here these are the values, and in calculation normally these values are denoted as or replaced by these factors. High heating value in megajoule per kilogram is equal to 0.328 multiplied by percentage of carbon plus 1.43 multiplied by percentage of hydrogen plus 0.15% oxygen plus 0.09% sulfur. It's a simplified form of the equation. In the case of dry wood, it is an aggregate of the composition of dry wood is it contains cellulose, hemicellulose and lignin. It contains around 40 to 45% cellulose, 20 to 30% hemicellulose and 20 to 30% lignin based on the type of the biomass. You can see in this table the carbon, hydrogen, oxygen, nitrogen, sulfur and ash content of the wood with the various composition of water, like 0% water it has a low heating value of 19,900. If 20% is present, it gets reduced to 15,400. If 40% water is there, it around 10,950, and if 60% water is present, it produces 66,500 kilojoule per kilogram. So, as per the water content increases, you can see the differences in the carbon, hydrogen and oxygen content, while the nitrogen and sulfur content, sulfur is normally absent in the biomass, the nitrogen content also reduces. This table shows the comparison of different fuel with respect to its different properties. So, students, to conclude this module, we have seen that different properties of the different fuel. We have seen the properties of liquid fuel like diesel, gasoline, etc. In this, the most important properties were viscosity, which is the resistance to flow, and we have seen the calorific value of various liquid fuels. We have seen the what is density, specific gravity, specific heat, ash content, moisture content, etc. In the case of properties of the gaseous, we have seen the various the properties of the gas like heating value, how it is affected with the moisture content, etc. And we have also seen in detail the properties of solid fuel, especially the coal. We have seen there are two types of analysis, ultimate and proximate analysis. In the proximate analysis, we mainly focused on the fixed carbon, the volatile matter, the ash content and moisture content. While in the case of the ultimate analysis, we mainly focused on the elemental analysis like percentage carbon, percentage hydrogen, oxygen, sulfur, nitrogen, etc. We have seen that different coal varies, or the properties of the different coal varies with its moisture content, ash content, even the location also. Especially in Indian context, we have seen that our coal is of low grade, which is having the low heating value, and we have seen the parameters. We have seen the parameters, how these are measured, mainly what are the instruments used for this purpose, and also we have seen what is the significance of these parameters with respect to the fuel purpose. Thank you.